sky over the battlefield was silent, except for the rolling rotor blades of the AH-64 Apache following a hostile tank. Ever since the introduction of the Hellfire, pilots or operators have needed to decide how to engage a target using the two main variants of the legendary missile at their disposal: the Romeo, laser-guided and deadly precise in clear conditions, or the Longbow, its radar unflinching through smoke and storm. But after decades of service, the legendary Hellfire missile has a replacement on the way in Lockheed Martin's AGM-179 Joint Air-to-Ground missile. The JAGM builds upon the Hellfire's low-cost, high-accuracy legacy by mashing multiple targeting systems into a single weapon. With the AGM-179 JAGM, the pilots can simply engage targets with the same missile, regardless of the environment or situation. This is the future of warfare, where one missile does it all. No more choices, just swift, precise, and lethal action. In the 1970s, when the United States Army was seeking an effective anti-tank weapon for rotorcraft like the Vietnam War classic AH-64 Apache, the Martin Marietta Heliborne Laser Fire and Forget missile, or Hellfire, soon became a staple of the U.S. military and beyond. When tested in battle, the Hellfire was so effective that new iterations of the technology expanded its original role. Today, the missile is the primary 100-pound class air-to-ground precision weapon for the United States Armed Forces and many other nations. In addition to helicopters, the missile has been fitted aboard fixed-wing aircraft, watercraft, and even land-based launchers in a surface-to-air capacity. One variant, the AGM-114R9X, swaps its explosive warhead for a set of 6 deployable 18-inch blades. Now a family of Hellfire missiles, the most used variants include the AGM-114R Hellfire II, commonly known as the Hellfire Romeo, and the AGM-114L Longbow Hellfire. These two missiles share several elements, including warheads, yet they differ dramatically when it comes to targeting, forcing users to maintain separate inventories of each. The Romeo missile is quite similar to its predecessors, using a highly accurate semi-active laser guidance system to deliver 20 pounds of explosives to targets over 6 miles away. This wonder weapon is the primary air-to-surface weapon for several platforms in different branches, like the Army's AH-64 Apache, the Marine Corps' AH-1W Super Cobra, and the Air Force's long-loitering MQ-9 Reaper drone. Meanwhile, the AGM-114L Longbow swaps out the laser guidance system. Instead, it uses a millimeter wave radar that allows high-accuracy performance beyond line-of-sight ranges, or in environments with bad weather or heavy smoke, which can compromise the efficacy of the Romeo variant. While the former tends to be the general-purpose air-to-surface missile in Army and Marine inventories, the Longbow is the main anti-tank weapon system for the world-renowned tank hunter Apache helicopter. However, as warfare evolved and the battlefield's demands grew more complex, despite the accuracy, the Army recognized the need for a more advanced, versatile weapon system. But replacing this icon of warfare would not be an easy job. In 2007, the Pentagon kickstarted a high-stakes contest to develop the next-gen Joint Air-to-Ground Missile, or JAGM, a project set to redefine military firepower. By the following year, aerospace titans Raytheon and Boeing had joined forces, earning a $125 million deal, while Lockheed Martin, the creator of the Hellfire missile, secured a similar contract. Despite facing the chopping block in 2011 due to budget constraints and the Navy and Marine Corps temporarily pulling out of the project, the JAGM program clung to life. In 2013, the Army announced that Raytheon's contract would not continue, leaving Lockheed as the sole potential contractor. Fast forward to 2015. The designation AGM-179 was assigned to the JAGM program, and a low-rate initial production contract was approved in 2018. Until then, Hellfire missile operators would need to decide which of the two main variants to use. The Romeo, accurate only if and when it has a direct line of sight, or if there's bad weather or an enemy-made smokescreen, the Longbow's millimeter wave radar is more effective. But according to Lockheed Martin's Joey Drake, JAGM program director, this is all about to change. With this new missile, pilots can skip this question and simply engage targets with the same weapon, as it combines semi-active laser guidance and Longbow's millimeter wave radar into a single system, paired with the already existing warhead, motor, and flight control system of the Romeo missile. As such, the mission gets completed, no matter the weather or situation. As stated by Drake, the AGM-179 JAGM represents, quote, one missile, multiple platforms, multiple missions for all the services. Despite its promise, the weapon has overcome many obstacles and fine-tuning. During testing in the mid to late 2010s, the U.S. Army experienced several failures during live fire testing from an AH-64E Apache helicopter, including seeing the missile miss 2 targets. During a significant test, one of the 4 launches with a live warhead failed to detonate. According to reports, the service resolved those problems in subsequent testing and evaluation. In mid-2019, the Marine Corps struggled with JAGM aboard Bell AH-1Z Viper during an initial operational test and evaluation at Fort Hood and Edlin Air Force Base, Florida. During this, the Marines fired 2 shots, both of which did not hit boat targets at the center of the vessel and instead struck more toward the back. While the original plan called for a full-rate production announcement in 2021, the Marine Corps requested more time to complete platform integrations. But according to the Program Executive Officer for Missiles and Space, Major General Robert Raish, the delay did not affect the program's timeline. Finally, according to a Lockheed Martin statement from August 30th, 2022, the Army and Marine Corps have declared the AGM-179 Joint Air-to-Ground Missile ready for full-rate production. By then, a little over 1,000 missiles had been produced. This milestone also marks the completion of operational testing of the model in the Apache and Viper attack helicopters. Because the new AGM-179 shares a great deal with the Hellfires it's set to replace, it can be used with the existing launchers and infrastructure, and as such, will require very little training for ground crews and pilots. Additionally, having a 2-in-1 missile isn't only useful on the fighting ground, it's also great for the military budget. But this dual-mode weapon also means cutting down on the number of different weapons units have to keep handy while deployed, and from a logistics perspective, it's also an excellent interoperability advantage. In the event of a conflict, if America needs more ammunition for the fight, and Germany has a stockpile of it, it's a simple transfer, as both use the same rounds. This can also be applied to America's varied military branches. Deployed by the Army, Marines, and Air Force in a pinch, an Army Apache unit in need could draw JAGMs from a nearby Air Force Reaper unit with a surplus lying around until more munitions can be rolled out. And while hypersonic missiles and AI-powered drones are all the rage in defense development circles, the AGM-179 JAGM, although not as flashy, is just as important. In a major conflict with a superpower like China, advanced, costly military tech like $100 million boost glide weapons or cutting-edge stealth fighters would be strategically limited. While crucial, their high value and scarcity may mean that the Army will preserve them for pivotal moments rather than widespread deployment in such scenarios. Instead of these multi-million-dollar stealth fighters, of which America only has a couple hundred, winning a fight between technologically developed industrial nations will come down to the quick and efficient use of already available systems. Financial attrition can be a devastating weapon in large-scale warfare, as proven in many 20th century conflicts. But with new and improved systems like the JAGM, the United States and its allies can ensure they have the firepower needed to win, while still developing the firepower it will require for tomorrow's conflicts. Joey Drake, the Program Management Director of Air-to-Ground Missile Systems at Lockheed Martin Missiles and Fire Control, said the decision to move to full-rate production signifies the program's maturity and the Army's confidence in their product. In the near future, they intend to integrate the JAGM into helicopters, unmanned aircraft, and air defense systems. Meanwhile, the company has already announced the JAGM-MR for medium range, a further improved version with a range of 10 miles without changing the missile's dimensions. The version also incorporates a tri-mode seeker, a technology seen in Raytheon's mid-2000s proposal, which was dropped due to cost factors, but has since become much more affordable. As stated by Jerry Brode, Vice President of Close Combat Systems at Lockheed Martin Missiles and Fire Control, the JAGM has proven that it can be counted on when it matters most, both providing mission-focused offensive and defensive capabilities, and most importantly, maintaining a competitive edge against any potential adversaries. The transition from the Hellfire to the JAGM is akin to passing the torch. As the Hellfire, a symbol of 20th century warfare, hands over its duties to the JAGM, a weapon designed to confront the challenges of a new era with even greater precision and versatility, the stage is set for what may become the pillar of short-term warfare. The potential of this new weapon is endless. During the last 5 years, The most powerful militaries in the world have been developing hypersonic weapons systems capable of reaching 5 times the speed of sound. But as Russia and China stepped ahead of the United States, the Air Force initiated the Air-Launched Rapid Response Weapon Program, or ARRW, which led to the AGM-183A hypersonic missile developed by Lockheed. After a series of unsuccessful tests, the incredibly potent missile finally proved its worth in May of 2022, paving the way for a weapon that could eventually spiral to previously unthinkable heights. In May of 2018, the U.S. Air Force began an ambitious program to expedite the development of a hypersonic missile weapon system. Intelligence officers had expressed their concerns about rumors that China and Russia were already experimenting with these new weapons, and the U.S. intelligence community and the Department of Defense took the threat seriously. A hypersonic missile or vehicle can exceed speeds 5 times the speed of sound, or upwards of 3,800 miles per hour, and developing a weapon with such characteristics is no easy task. Fluid air dynamics at hypersonic speeds behave differently when compared to the speeds at which fighters and missiles travel. Will Roper, the Assistant Secretary of the Air Force for Acquisition, Technology, and Logistics, then announced that there was already a team evaluating how to develop a weapon with such features. The program was called ARRW, or Air-Launched Rapid Response Weapon. The Air Force, Navy, Army, Department of Defense, and the Missile Defense Agency signed a memorandum the following month to work together on the project. And on August 13th, the U.S. Air Force awarded a $480 million contract to Lockheed Martin to develop an air-launched hypersonic weapon. The cybersecurity strategy of the ARRW program received final approval 7 months later, and Lockheed accelerated the new weapon's creation. AGM-183A ARRW. The result of the ARRW program was the AGM-183A hypersonic missile developed by Lockheed. It is a small-sized, air-launched missile that is being developed to reach speeds of up to Mach 20, with an estimated range of over 575 miles. The AGM-183A works with a hypersonic boost glide system that uses DARPA's tactical boost glide technology. A rocket propels the payload to high speeds and then separates from it, flying like a glider towards the intended target. Afterward, the missile's aeroshell drops from a high altitude, and the hypersonic glider's warhead detaches to maneuver and impact the target while maintaining the same hypersonic speeds. The launch platforms that carry the American hypersonic missile are the B-52, B-1B, and F-15 aircraft. The advantages of fielding this type of weapon are numerous, as it can swiftly overcome contested environments with its superior high speed, maneuverability, and altitude. This allows the U.S. Air Force to strike time-sensitive objectives from standoff distances without compromising more valuable assets. The weapon's first flight test took place over Point Mugu Sea Range off the coast of California on April 5, 2021. A B-52 Stratofortress from the 419th Flight Test Squadron and the Global Power Bomber Combined Test Force attempted to launch the AGM-183A, but the missile was unable to complete its launch sequence, forcing the bomber to return to Edwards Air Force Base. Brigadier General Heath Collins, the U.S. Air Force's Program Executive Officer for its Armaments Directorate, said in a statement, quote, "The ARRW program has been pushing boundaries since its inception and taking calculated risks to move this important capability forward. While not launching was disappointing, the recent test provided invaluable information to learn from and continue ahead. This is why we test." The second missile test took place on July 28, 2021, in the same place as the first. This time, the B-52H successfully dropped the ARRW test missile, but its rocket motor failed to ignite after separation. Months later, after gathering more information about the previous mischiefs, the Air Force conducted a third test on December 15th. However, this test also failed, as the prototype missile never left the aircraft's wing. Brigadier General Collins told the press that, quote, "The launch sequence was aborted before release with an unknown issue. The missile will return to the factory, and analysis of the telemetry and onboard data will begin immediately. The program will seek to resume flight test as quickly as possible." The third attempt's objective was to demonstrate the correct functioning of the rocket booster and to study how the nose cone breaks apart and how the unpowered hypersonic boost glide vehicle is released. If it had been successful, the Air Force would have conducted another test to analyze the performance of the boost glide vehicle as it glided towards its target at hypersonic speeds. Retired Air Force General John Hyten, then Vice Chairman of the Joint Chiefs of Staff, expressed his concerns about the third attempt. Quote, "What you need to be worried about is that in the last 5 years, or maybe longer, the United States has done 9 hypersonic missile tests, and at the same time, the Chinese have done hundreds." On May 14, 2022, the Air Force announced that it had finally conducted its first successful hypersonic weapons test. Footage taken by the Air Force during the trial showed how the AGM-183A was gracefully released from a B-52H. Following the separation, the missile's booster ignited and burned, successfully achieving hypersonic speeds 5 times greater than the speed of sound. Collins's tone was different this time, telling the media that, quote, "This was a major accomplishment by the ARRW team, for the weapons enterprise, and for our Air Force. The team's tenacity, expertise, and commitment were key in overcoming the past year's challenges to get us to the recent success. We are ready to build on what we've learned and continue moving hypersonics forward." Additionally, Lieutenant Colonel Michael Youngquist, the 419th FLTS commander, noted, quote, "Our highly skilled team made history on this first air-launched hypersonic weapon. We're doing everything we can to get this game-changing weapon to the warfighter as soon as possible." The groundbreaking success of the ARRW hypersonic missile test in May of 2022 put the U.S. Air Force on track to close the hypersonic missile gap with China and Russia. The American test came weeks after President Vladimir Putin told Russian media outlets that his Son of Satan intercontinental ballistic missile could target the United Kingdom with unprecedented results. A second successful free flight of the ARRW then took place on July 12, 2022, and the Air Force stated that the exercise concluded the booster test phase of the program, clearing it for operational testing later in the year. In addition, several journalists have reported that Russia has been experimenting with air-launched hypersonic weapons as far back as 2020, as Su-57 stealth fighters have been spotted carrying prototype hypersonic missiles. A paper from RIA Novosti went as far as to say that these Russian missiles will include seeker heads and electrical circuits. Other reports have mentioned that Russia is developing more than one type of hypersonic missile. One of them is called Kinzhai, and it appears as though it will be employed by the MiG-31 Foxhound interceptor. If true, Russia may become the first country in the world to successfully field fifth-generation fighters with air-to-ground hypersonic missiles. Whichever the case, the U.S. Army, Air Force, and Lockheed Martin will continue testing the AGM-183A hypersonic missile before reaching early operational capability in 2023. If everything goes as planned, it could be only a matter of time before the U.S. Air Force starts mass-producing this new hypersonic technology. The most effective weapons in the world are seldom the most powerful solutions or the most technologically advanced devices. Instead, it's often the armament system that can be produced affordably and reliably which can change the fate of a war. Under such a perspective, the United States, Saab, and Boeing recently joined forces in an unprecedented operation to unite 2 of their most efficient, time-proven, and affordable weapon systems and merge them into something capable of shaping the future of modern warfare. The idea is to take the raw power, precision, and compact size of the GBU-39B air-to-ground missile and the reliability and mobility of the HIMARS missile launcher platform to create a formidable new ground artillery solution whose parts are already in mass production. The missile has been part of the U.S. Air Force arsenal for almost 2 decades, while the HIMARS redefined the concept of mobility and efficiency in ground artillery armament. By combining the two, the Weapon Manufacturing Collective promises to bring affordable and reliable new solutions to the world's most brutal conflicts. The weapon is now being rushed to the Ukrainian battlefront, where it will be tested in combat for the first time, while boldly taking massive aerial firepower to the ground. Recent conflicts like the Russian invasion of Ukraine have shown that being able to support allies in battle with massive quantities of affordable weapon systems, capable of offering protection in extensive territories, is as important as delivering a few highly technologically advanced weapons that cannot be broadly deployed. But affordability is not the only reason to pursue the creation of weapon systems based on already widely available technology. Training is also a crucial factor. The Ukrainian forces are mostly unfamiliar with the most advanced Western armament systems. Even if they could be delivered to them in large numbers, the training infrastructure needed to make them effective would take too long to develop. Nevertheless, the problem has been directly addressed by the United States in collaboration with the Saab and Boeing corporations, which had to develop what they call the Ground-Launched Small-Diameter Bomb, or GSDB system. Such a system takes advantage of low-cost, previously demilitarized armaments, such as the multi-launch rocket system booster, by marrying it with a small-diameter bomb air launch platform. The result is what the coalition calls, quote, a revolutionary product. The new system's main advantages are its affordability, ease of use, and availability. Moreover, the weapon offers a wide array of tactical combat features that make it stand out in the current market. In addition, the GSDB integrates the air-to-ground GBU-39 small-diameter bomb and the M26 rocket motor, widely available in U.S. stockpiles, and is equipped with GPS guidance, can overcome electronic interference, and can be utilized in any weather condition. According to Saab's website, it can defeat armored vehicles, launch attacks against air defense bunkers and caves, and has a margin of error of less than 1 meter. The system is unique in that it combines a long range with the capability to fire up to 6 weapons simultaneously. In addition, it has a new ground artillery feature, enabling it to target any angle, including those on the reverse slope of mountains. This is a significant breakthrough, as one of the weapon's developers explains, quote, "The enemy today is trying to stand behind mountainsides and things like that to avoid being engaged by ballistic missiles that can only do one type of engagement. But the GSDB does not have that limitation, which means no matter how the enemy positions itself to protect its assets from artillery attacks, it will be fair game for the new glider missile." The GSDB system has been proven effective and safe during its testing phase. However, the weapon has not yet been utilized in combat scenarios. That is about to change, as the United States is doing everything in its power to rush the affordable and devastating missile solution to its Eastern European ally. As of February 2023, the United States intended to send more than $2 billion worth of military aid to Ukraine. More than half of that money would go into the newly created Ukraine Security Assistance Initiative, or USAI, which gives President Joe Biden's administration the ability to acquire weapons for Ukraine directly from the arms industry, rather than from American weapon stocks. The USAI funds will be used to purchase the ground-launched small-diameter bomb produced by Boeing and Saab. Apart from its multiple angles of attack, the weapon has a range of 94 miles, allowing Ukraine to target previously inaccessible targets and support its counterattacks by disrupting Russian forces deep within its territory. After the United States declined Ukraine's requests for the ATACMS missile on several occasions by claiming that its almost 200-mile range would risk escalations with Russia, the GSDB is expected to be an ideal solution that will allow Ukraine to extend its operational artillery range without risking more tensions. While the US and most European countries continue to be hesitant in providing Ukraine with more advanced weapons capable of reaching further into Russia, the GSDB appears to be a formidable compromise that significantly expands Ukraine's reach and ability to defend itself without overstepping the often hazy line that would lead to more conflict with Russia. The GSDB is designed to be launched by already widely used ground-based missile systems, such as the M270 multiple launch rocket system and M142 HIMARS. The HIMARS is a simplified, less armored version of the M270, which is much more mobile, light, and affordable. The Ukrainian forces have at least 15 operational M270 MLRS and over 20 HIMARS provided by the US. With another 18 HIMARS currently in production and expected to be delivered soon to Ukraine, the missile system is highly familiar to Ukrainian troops and has been used with lethal efficiency. As such, adding the GSDB to its roster of guided munitions will significantly enhance what the Ukrainian military can do with its available artillery systems. After the projectile is launched by the HIMARS system, its newly incorporated M26 rocket motor takes over to deliver the bomb as close to its target as possible. As it cruises, the navigation system allows it to be navigated around obstacles like mountains and known anti-air defenses, contrasting traditional artillery that follows a parabolic arc towards its objective. Once above its target, the bomb uses its air-to-ground features to accurately glide down to its target and even reposition itself to engage the objective from different angles of attack. This capability negates the protection of mountainsides and rough geography. The relatively cheap solution is expected to deliver significant advantages to the Ukrainian military. At the moment, the Guided Multiple Launch Rocket System, or GMLRS, is Ukraine's longest-range weapon, with a range of roughly 48 miles. As wartime technology evolves, more projects such as the GSDB can be expected to appear as the world demands an effective and affordable solution that can be developed out of already available components. Only time will tell how this new development will reshape the future of how wars are fought. In the skies above a distant battlefield, an unprecedented encounter unfolds. A sleek, sixth-generation stealth jet, armed with the U.S. Air Force's latest weapon, the MUTANT missile, closes in on an elusive and highly maneuverable enemy aircraft. The pilot's heart races as he locks onto his target, aware that traditional air-to-air combat tactics are futile against such an adversary. But the MUTANT missile is no ordinary weapon. Born from decades of research and cutting-edge technology, it has an ace up its sleeve, an articulating nose that bends and twists to track its target with unwavering precision. With a heart-stopping roar, the missile leaves its launch rail, and the chase begins. The enemy aircraft twists and turns, attempting to evade the relentless pursuit. However, the MUTANT missile's morphs are shaped mid-flight, a feat that gives the projectile extraordinary agility. Onlookers at the 2023 Air and Space Forces Association's Warfare Symposium gasp in awe as the enemy aircraft makes one final desperate maneuver and the MUTANT missile strikes. A brilliant flash lights the sky, and air-to-air combat is forever changed. As far-fetched as the MUTANT missiles may appear, the concept derives from a technology that has been developing for several decades in the world of aviation. The idea envisions a world where aircraft can effortlessly adapt their shapes mid-flight, transforming to tackle a variety of missions with agility and precision. Morphing technology is the key to unlocking this awe-inspiring vision, enabling aircraft to alter their wing configurations and aerofoil properties for peak performance. With a history spanning over a century, the revolutionary concept has evolved from simple wing twist adjustments to sophisticated cutting-edge mechanisms. The journey of morphing technology encompasses numerous milestones, including creating adaptive structures, materials, and aerodynamic optimizations. Recent breakthroughs focus on stability and control during morphing, as researchers unveil innovative methods, such as adaptive neural control, LPV models for longitudinal dynamics, and finite time-boundedness robust control. Morphing aircraft can now offer additional control surfaces, allowing trajectory attitude separation control and enabling more precise observation without visual disturbances. But the potential doesn't end there. Researchers continue to push the boundaries of morphing aircraft technology, striving to enhance stability and controllability during rapid structural changes, redefine dynamic models for morphing processes, and discover groundbreaking control methods. As these advances materialize, morphing aircraft will soar to new heights, becoming more efficient, versatile, and adaptable. The transformative power of morphing technology isn't limited to aircraft. Projectiles are also an essential focus of morphing technology development, as their compact, resource-limited structures could drastically benefit from being able to change their shape mid-flight. Several guided missiles can already correct their course in flight as they approach their target. Still, their agility and speed when doing so are limited to the aerodynamics of the projectile and its propulsion system. A missile that can change its shape to compensate for a drastic course correction would result in a weapon with a much superior range and effectiveness against elusive targets. Projectiles can continuously adapt their outer mold line by integrating advanced actuation systems and composite high-strain skin structures, unlocking unparalleled agility and maneuverability. The U.S. Air Force is on the verge of a game-changing breakthrough. A new system, known as the MUTANT missile, is being developed to increase range and effectiveness against highly maneuverable targets at a limited cost. This active morphing capability is achieved through the innovative Articulation Control Actuation System, or ACAS. The ACAS represents a leap in weapons technology, featuring a composite high-strain skin structure enveloping an internal electromagnetic actuation system. This allows the missile's forebody to be a flight control surface, augmenting its air-to-air axisymmetric effectiveness. Current missile control actuation systems face a trade-off between range and maneuverability. Still, the ACAS seeks to overcome this limitation. Morphing weapons technology like the ACAS enables continuous outer mold line change to tailor a performance to each phase of flight. Aerodynamic drag is not affected in mid-course, while the large surface area of the missile forebody provides agility and moderate improvements to maneuverability during terminal homing. The result is a significant net benefit to missile performance when ACAS size, weight, and power or SWAP requirements are met. Intended to be fitted onto the Next Generation Air Dominance Program's 6th-generation fighter aircraft, the MUTANT missile concept is suitable for air and ground-launched missiles. The Air Force Research Laboratory has advanced ACAS technology readiness after 6 years of research under the MUTANT program. They have learned to design, fabricate, integrate, and employ the ACAS on a missile with 3 ground tests scheduled through 2024. These tests will be performed on the Hellfire missile, which is not necessarily the technology's intended application platform. The progress of the MUTANT missile and ACAS technology highlights the continuous advancements in aerial combat capabilities, setting the stage for a revolutionary change in air-to-air warfare. As the U.S. Air Force moves towards integrating this cutting-edge missile technology, the future of aerial combat will be transformed forever. The coupling of the Next Generation Air Dominance Program's 6th-generation fighter and the MUTANT morphing missile is paving the way for a new era in combat aviation. As things stand now, plans suggest the 6th-generation fighter will be designed with advanced avionics and network-centric capabilities, in addition to advanced artificial intelligence systems that will achieve seamless integration with the MUTANT missile. This will enhance the situational awareness of the fighter pilot and allow for more efficient targeting and engagement of enemy forces at longer ranges and with lethal accuracy. Thanks to these emerging technologies, the U.S. might get an unparalleled advantage in aerial combat in the near future. Imagine the scene. It is a crisp morning as the young American pilot climbs into the cockpit of his state-of-the-art 6th-generation fighter. This sleek, stealthy aircraft hums with energy as its advanced systems come to life. Today's mission is critical, neutralizing a heavily fortified enemy airbase deep within hostile territory. As the fighter races across the sky, its advanced sensors and AI-driven avionics scan the battlefield, identifying enemy positions and assets. The fighter seamlessly shares the information with nearby Allied aircraft and ground forces, allowing them to coordinate their attacks with unprecedented precision. As the fighter approaches the target, the pilot receives a warning from the AI assistant. A swarm of enemy 5th-generation fighters is closing in. Undeterred, he unleashes a single MUTANT missile, which immediately dashes towards its target, morphing and adapting its shape as the enemy aircraft attempts to evade. The targeted fighter, caught off guard by the missile's agility and adaptability, cannot evade the incoming projectile. Emboldened by the victory, the pilot continues to hunt down the outclassed fighters. One by one, the enemy aircraft are systematically taken out of the sky, their advanced defensive systems unable to cope with the morphing capabilities of the MUTANT missiles. The combination of the 6th-generation fighter and the MUTANT missile morphing technology proves too much for previous generation contenders. The breakthrough becomes a game-changer in aerial combat. The future of warfare has arrived. And with it comes a new era of dominance for U.S. forces equipped with this revolutionary technology.